Thanks for joining us for the third installment in this application modernization series. In our last episode, we explored the architecture of an application modernization initiative. In this episode, we're going to look at containers and their orchestration. And to kick this conversation off, let's loop back with Dewan Ahmed to get a brief history of how and why containers came to be.
Before we actually talk about containers, we have to go a step back and talk about virtualization era. So in virtualization era, you have your VMs. I'm not going as far as the physical servers because that's going too far and a lot of our listeners might not even remember that time. But let's start with virtualization. So when you have your VM, the application that's running on your VM, it's using all the resources. That means the memory, the disks, everything it's using up. But that's true for any size of application. That means if it's a tiny web server or it's a giant web server, it's using the entire virtual machine. So there was no way of allocating resources just based on the need. So that's when containers came into play. So container is using shared resources. And when we mean resources, it's sharing the OS and the resources that the OS is accessing. So the physical disk and the memory and whatnot. The main benefit is if you're thinking like a chunk, so you can slice up the resources and your application can only use what's needed. So now coming back to containers. So what is containers? And a lot of people try to talk about shipping containers, and security folks have a big no to that because when you talk about shipping containers, inherently it seems that it's secure, whereas it's the opposite. So if you think of a house versus an apartment, if you try to go into a house, you occupy the whole house. So someone can knock into the front door. If they access, that's your entire house. So that's similar to VM. Containers, think of like an apartment. So in an apartment building, the whole building, let's say that's one virtual machine, but that virtual machine can run, let's say 20 containers, just giving up some numbers there. But you can actually go inside the building and knock on each person's door. So it's less secure. Of course, it has the pros and cons. The pros being you can do much more resource utilization. The flip side is you don't have as much grip on the security and some other points as well. So to one line answer is container is a new way of running your application where the resources of memory and disks and everything and OS, it's shared with the host.
So thanks to Dewan for giving us that great overview of what a container is and the motivations for their rise. I thought it was interesting that what Dewan had to say about security was very similar to what Brandon had to say. Later in this episode, we're going to hear more from Brandon about how to practically implement effective security for containerized workloads. But first, I wanted to hear more about containerized workloads from a developer's perspective. So I looped back with JJ in Austin, Texas.
Okay, so long story short, when it comes to containers, you know that famous statement you hear from every developer at some point in your career, well, it worked on my laptop. That's what a container is. In essence, it's a way to ship exactly what works on their laptop into another layer of infrastructure. So let's just take a quick moment and say we have my dev laptop, we have a QA or a UAT environment to make sure it works how we expect it to, and a production environment. A container, if you've packaged up it properly using the OCI model that we have now, which is a standard of how to make a container run on Kubernetes, OpenShift, or whatever, if you go by that spec and containerize it, it will run in dev, QA, and production without a problem. Containers are a way to break up a service instead of just one big monolithic app. It encourages you to do microservices-based architecture. As long as you can build your application in a microservices-based architecture and start really embracing the velocity you need for your developers, it really doesn't matter where you run your application anymore. Because you have this standardized way that your application is built and ran. Now, let me take a quick step back and make an analogy. And I'm just going to say the mid-90s, there's this language they call Java that appeared, and all of a sudden you can run Java anywhere. That's pretty cool, right? I mean, we still use it today. Well, put your head around Kubernetes and OpenShift, and you've got to realize there's a lot of people out there who honestly don't want to program in Java, or it doesn't do what they need to do. OpenShift and Kubernetes actually is the same level of cultural shift that Java had in our industry, but with any language. Containerization allows you to take any language, turn it into a container, and run it. So the promise of Kubernetes is that as long as you set by that OCI spec, it can run on-premise, in the public cloud, in your private cloud, and still run exactly how you expect it to. So just take a moment and really think about that, saying that you can have those people who only know Node or JavaScript, however you want to describe it, and they can run their app and have the power to deploy their app into an infrastructure that they can now just take advantage of. You might have a C++ program that's the best one on the world, but they can't do anything on the web because they've only done everything in hardware or whatever. Well, you give them the opportunity to containerize their application. Now all of a sudden they can do all that work you've been trying to get them to do. It's a massive paradigm switch that has some huge advantages.
When JJ brought up that famous line of, "It worked on my laptop," I was totally transported back to my startup days, where we had weekly struggles because we had a pre-containerized cross-OS development system. And I'm sure when my college roommate hears this episode, he's going to chuckle and maybe sob to himself. But that's a story for another time. Back on the trail of application modernization, here's what Brandon had to say about containers from a security perspective.
Containers are like this intermediary step, because the cool thing about containers is they can land anywhere, right? So they can land on premise, they can land on some private cloud, they can land on a public cloud, right? So we're seeing a lot of clients use containers as almost an intermediary step, right? It's like, I'm gonna take this monolithic architecture, I'm gonna break it into microservices, and I'm gonna put it on my on-prem stuff, knowing in maybe 6 months to a year, I'm eventually starting to migrate that over to AWS, IBM, Azure. So yes, that's something we typically see. And, there's caveats with security on that, right? Of course, I could bring up OpenShift and talk about that, but the cloud native container functions like EKS or Azure Kubernetes, they're not as mature when it comes to a security implementation as some orchestrators are, like OpenShift. So there's some things the client or the container owner needs to do to ensure those containers are secure that the cloud service provider says is not my job. That's something on you, right? So there's a little bit of a disconnect there. I think that'll mature as container adoption increases, which it's increasing day by day. I think it's like up to 80% of people are using containers in the market. So we'll see.
Well, thank you for those insights, Brandon. It's really interesting. While containers can run everywhere, you really have to be cognizant of where and how you're running your containerized workloads, because not all platforms running containers have the same maturity with regard to security. We're going to be talking more about security in our next episode. In fact, the whole episode is dedicated to the subject. So please join us next time for episode 4 of our series on application modernization, security.